Here the concept is what is an objective function. See, if you take the objective function general form, first of all, it is a linear function. Why? Because the powers of the variables, say x, y, or sometimes even x, y, z, it will be called as the function where the variables power should be is equals to how much? 1. Right. So that's why it is called as a linear function. And the linear function is of the form z is equals to ax plus by, right? Where a and b are the constants, where a and b are the coefficients, which has to be maximized or minimized. See, before going to the concept of this maximized or minimized, we should think about a little bit about the linear programming problem. In the linear programming problem, there are some linear inequalities, and these linear inequalities, if we substitute in the graph, we will get some regions. Maybe some origin will be lying, or sometimes some origin will not be lying in that region. Like that, we will plot some 3 or 4. While when you substitute some 3 or 4, we are going to get a common region for the given linear inequalities. That common region we can shade so that we can get the vertices. The vertices so obtained for this will be called as the where vertices of the convex set or vertices of the solution. And if we substitute these vertices in the objective function, say z is equal to ax plus by, some values will be maximum, while some values will be minimum, and some more values will be in between maximum and as well as the minimum value. So the values which will be less when compared to the obtained values, the values so obtained, we can call it as a minimum value. And the value which is greater than the among the values, which is the greatest value among the given values, after substituting the values of x and y, we will call it as a maximum value. So in some problems, there might be one unique maximum value and one unique minimum value. Whereas in some types of linear programming problems, there will be two maximum or even sometimes three maximum, or there may be two minimum or sometimes three minimum values also. And like that, we are going to get the maximum value and as well as the minimum value. And the linear objective function x comma y are said to be the decision variables. We'll call the x comma y are the decision variables. Because of this x and y, the values which you are going to get, we'll call them it as the variables, which you are going to decide whether it is a maximum value or as well as the minimum value. That's why the variables which are used in the objective function, so called as x comma y or x and y, we'll call them it as the decision variables. Because of these variables, we can judge which one is maximum, which one is minimum. And of course, we know that in the case of decision variables, x and y, they are strictly non-negative. Usually, we'll take in the first quadrant. The solutions should be considered only in the first quadrant, not in the second quadrant or third quadrant. So at last, the linear function which is of the form z is equals to ax plus by, where a and b are called as a constants, and which has to be maximized or minimized is called as a linear objective function.